Hello guys, welcome back. Now at this stage that we were able to just complete our stand model, and we just saved that in a file as model underline b underline ad.stand. And now we are at the stage that we just execute that file to see that if we just get to a convergence, then we can just reliably sample and draw from the posterior distribution that we are just going to have. At this stage, I have written the codes here. You remember from the previous module and also the previous courses, we just called the function stand. I specified the name of the file which I'm just going to have, and also I specified the data as a list which I did create in the previous step. You see that data stand model B, it's the list, and also I just set the number of the convergence to be for thousands, and I'm just running that over 4 different chains. Now I'm just going to execute the file. It may take a couple of minutes depending on the power of your the processor. Then we are just going to do some kind of diagnostics tools to see that if we just got to a convergence, then we can just draw from our posteriors. It may take a couple of seconds or a couple of minutes. I'm just going to pause the recording. When the recording is done, when the processing is done or towards its completion, I get back and we continue from there then. Okay, now the processing is done and all the chains have been just, I should say, were completed in terms of, I should say, finding the least gradients. And now the thing that we just want to do, we just want to quickly check to see if the model has converged. If the model has just met the convergence, then we just can go on and just draw from the posterior distributions and find the value, the best estimates for the parameters of our interest, which is going to be slope for the brain atrophy in our model. In order to check for the model convergence, you see that one of the things that we can just do is to use the trace plot, and I'm just going to use the model B. I'm just going to execute the line by pressing Control Enter. Also, the other option that we have, and I just covered that on the previous lessons that we had, we can just use the Shiny Stand package. Okay, I'm just gonna zoom on the figures. Let's see how it's done. We see that the sigma, which shows the standard deviation, seems that has properly converged. And we have U1 and U2 and U3. And also we have sigma U. Each U refers for the random intercepts of each of the levels within the group. If you remember, 1 shows the converted, 2 shows the demented, and 3 refers to the non-demented. If you go back to the place that we just worked at the data exploration, and we showed how to just assign the numerical values to each of the categories in our group, you remember that we assigned number 1 to the converted case, we assigned number 2 to the demented case, and we assigned number 3 to the non-demented case. The sigma here shows the standard error, and sigma U shows the standard error of the distribution of the random intercepts that we just took that as a normal distribution. And you see that here also the bar ones shows that the replicated one, because at one single window the stand shows the 10 plots. We couldn't get all the normalized whole brain value bars then, volume bars then. And now, as long as we have this one, it's also a good practice to see that if the R-hat statistics shows the convergence. If you are not feeling comfortable about the plots that you got, you can also increase the number of the iterations, or also, as I have talked about that in the previous course which I had, you can tune the parameters of your model by changing, I should say, for example, the step size and the tooth, for example, step that you have in your model. Now at this step, we also want to see the print of the model to see that if the R-hat statistics just is at its optimal value, which is going to be around 1.1. If that's going to be the case, we've seen that, okay, we are just going to be fine with the number of the iterations that we have had. Then we just move on to just draws from the posterior distribution. You see that I'm just moving up. I'm just going to go ahead here to the R-hat statistics. And you see that for the sigma, U1, which is, I should say, the random intercepts for the converted case, U2, which is going to be the random intercepts for the demented case, and also for U3 is going to be the random intercepts for the non-demented case, and also the rest of it, we just have the optimal value, which is going to be around 1.1. And it shows that, okay, by doing two methods for the trace plots and also the R-hat statistics here, we just met the convergence in our model, which is going to be a good sign in order to move on and draw from the posterior. And in order to just draw the posterior, I'm just going to do that at the next tutorial, because it's going to take a little bit more time, as we're just going to draw from the posterior distribution and estimates for the parameters of our interest, which is going to be the random intercepts for both of the converted, for the demented and non-demented cases, compare them and visualize them, because it takes a little longer time. I'm just going to stop this tutorial at this point. Then when we come back at the next tutorial, we just go more into depth to see that, okay, what is going to be the normalized whole brain volume between the converted case, demented case, and non-demented case when they are at the age of 60. Okay, when we come back, we're just going to explore that more in details.